Hello, my name is Jeff Silberman and I'm a solutions architect with the Cisco UCS product group. This brief video is part of the broader UCS Advantage collection designed to highlight some of the more powerful and meaningful aspects of Cisco's unified computing system. This segment is going to cover the cloning and redeploying of servers within UCS. And within this short video, we're going to cover a fairly broad set of concepts within UCS demonstrated with two different live use cases. In data centers, the highest order operational concern really centers around application and service availability. Any provider of services needs to guarantee service delivery regardless of any possible failure, small or large. The applications must always be available. We're going to focus first on the class of applications that run on bare metal non-virtualized servers, since virtualized applications already have the benefit of things like vMotion. With Cisco UCS, a bare metal server is represented by a logical entity that we call service profiles, as you may know. These are hardware-independent definitions of a server that are not bound by physical hardware and cabling. In UCS, the actual representation of a server can be best seen by examining a UCS configuration backup, which can be seen here as a text-readable, hierarchical XML database. So the representation of this production exchange server, Exchange 1, can be seen here and includes the server's MAC addresses and worldwide port names as part of the server's definition. This Exchange 1 service profile was actually instantiated from this service profile template, which provides a way of enforcing a consistent set of policies and consistent hardware identifiers across all service profiles that are instantiated from this template. Now, from an availability standpoint, we have the opportunity to associate this template with what we call a server pool, which is actually a set of physical servers. Associating templates with server pools provides a great way to ensure availability. In this case, if this Exchange server's physical blade becomes disabled or decommissioned like this, then the Exchange 1 service profile will automatically reassociate and boot from another blade within the same server pool, just like you're seeing now. And this process takes about 4 to 5 minutes, which is about the time it takes to reassociate a service profile onto a new blade. So that's how UCS can help provide higher levels of service availability by redeploying servers within a data center. But what about providing higher levels of service availability between data centers? In other words, if the data center running this UCS domain, SF-prod, with Exchange 1 were to encounter a disaster, then what would be needed in order to restore service from a recovery data center site that would be running a completely different UCS domain? Well, remember that in UCS, the server is really just this XML file, including all of its so-called hardware identifiers like MACs and worldwide port names. So here I have an administrative view of two completely different UCS domains, SF production and Boston DR. Different domains, different chassis, and possibly different physical locations. Now, as part of a best practice, the SF-prod domain might be designated as the gold repository for all UCS policies, pool names, and template definitions, with the Boston DR site merely importing the gold policies, pools, and templates, and then ensuring site uniqueness for identifier pools, VLANs, and SAN targets if needed. There are usually a few different local site considerations to factor, but the basic concept still holds true. Everything that makes up the definition for the Exchange 1 server is independent of the hardware, independent of the UCS domain, and independent of the entire data center. To simulate a disaster recovery scenario, I'm going to use this PowerShell script to move or copy or clone a service profile from one UCS domain to another. One of the most important things to note here are the worldwide port names for Exchange 1, AA0E and AA1E. The script itself is quite short, with most of the work being done by this commandlet, sync UCS manage object, that forces consistency between the UCS domains with respect to the Exchange 1 service profile. Here, I have the context for both domains, sfprod and Boston DR, in these variables, as you can see. And now I'll call the move sp script with sfprod as the source and Boston DR as the destination, and using the Exchange 1 as the service profile. Now, in an actual DR scenario, the DC LAN and SAN configurations would have to be replicated for both the switches and the storage. But here you can see, once we run the script, Exchange 1 is effectively removed from the sfprod domain and is imported into the Boston DR domain. And when we check the worldwide port names, we see that we've maintained the exact same identity across this move. So before concluding, I'll note again that I've glossed over the complexities associated with SAN and LAN replication in a DR scenario, but let me recap